So 5.3. The fundamental theorem of calculus. Okay, so your book changed that. So part 1, part 2 is a switch. Normally other book is a different one. So fundamental theorem of calculus, part 1. F is continuous in closed interval, and we have a function, the f of x equal to integrate a to x, f of t dt, then the capital F prime of x equal to over the closed interval. Okay. All right. So this is very easy. Okay. Find the derivative of g of x equal to 1 to x 1 over tq plus 1 dt. Okay. So we have fundamental theorem of calculus part 1. We're gonna use that. Basically find the derivative of this one, right? That means g prime of x. What this mean? This means we derivative whole thing. Do you agree? So what do you get this one? We do antiderivative for this one, right? Antiderivative, then derivative, what do you get?
If we undo it and then redo it, is it just the same thing?
Same thing, right? So we get same thing, but we put the x, right? So it's same thing. This is the answer. How easy for this one? Can you believe that? But then it must be have the restriction is the any number for the lower limit. Okay, just a lower limit for a, any number is okay. Upper limit only for x. Is there more than x, then we have to use chain rule. Okay, for example, if we have 1 to square root of x. So f prime of x. So basically we do that. Okay. Look, in this case, more than x. We have a square root of x. Then look this one. Let u equal to square root of x. Now we do derivative, left side. Then right side, what do you get? Square root of x. One over 2 square root of x, right? I understand what you said. But then, look, we get sine. So let me using like u. We change that. Hold on 1 second. We will change 1 to u of x sine t dt. Then we do derivative then we have sine u over x du over dx. Sine u was the square root of x. What's du over dx, which is 1 over 2 square root of x. Okay, then this is 2 square root of x sine square root of x. Make sense? Basically, we add a chain rule there. That's it. Can you see that? If there is more than x in the upper limit. Let me erase this one. Okay, how about fundamental theorem calculus part 2. This is the last one. So if we have the integration, then f of b minus f of a, the f is any antiderivative, right? Okay. So for example, if we have, how about from I want to do from 0 to 2, t squared minus 4 dt. Okay, so we have two terms, so we can split. So antiderivative using power rule. So we add 1, divide by new power, and then we're going to evaluate from 0 to 2, right? Then we have 4, and then power rule, so 4t, and then we're going to divide by new power, which is 1, and then we will evaluate from 0 to 2, okay? And this will be 2q minus 3, and 0 minus 4, 2, and this is 0, right? And so 8 over 3 minus 8, what do you get? 8 minus 24. A minus 24. Thank you, negative 18 over 3. So we get the negative. This means below x-axis. Because of definite integration, we talk about the area under the curve, right?
I think it's negative 16.
16?
Yeah.
Okay. Oops.